Last time we looked at parent functions and we looked at graphs or equations of transformed functions, and we were asked to write what transformations had occurred. Today we're going to do the opposite. We're going to look at a parent function, be given a description of a transformation, and we have to write the equation of that transformed function. So we will start with vertical translations, and then horizontal translations, reflections in the x or the y-axis, vertical stretches and shrinks. We talked about all of those last time. And then finally, we're going to talk about horizontal stretches and shrinks. This is new for today. We didn't do horizontal stretches and shrinks before, so this is new. All right. So let's go ahead and take a look at vertical translations to a function f of x. So the first thing that we need to do is remind ourselves of what a vertical translation to f of x looks like. And it looks like our original function f of x and then plus some constant k. That k value shifts the graph up when k is positive, and if it's negative, it will shift the graph down. So let's take a look at a couple of examples of this. Our first example, and in these examples, we're wanting to write g of x, the transformed function of f of x. Our first example is that f of x is equal to x squared, our quadratic parent function, and we want to move it up 3 units. So let's first write what the rule will be for this. So g of x is going to take our function f of x, and it's going to move it up 3, so we're going to add 3 to it. Now, we know that f of x is equal to x squared, so we are going to substitute x squared where you see f of x here in this equation. So x squared plus 3 is our final transformed function, g of x. Second example, we're starting with our linear parent function. F of x is equal to x, and we want to move down 4 units. Again, starting with writing our rule for what happens to f of x, we would say that g of x is equal to f of x minus 4. It's a negative because we're headed down by 4 units. And then if we plug in for f of x, we know that f of x is just equal to x, so we can write this as x minus 4.